We are disassembling a electric skateboard battery, Meepo Mini 2ER. And just a second ago, there was a spark. I'm kinda scared now.
I had a problem with my electric skateboard. The battery in it would die at 50%, so I decided to take it apart, measure capacity of every cell, replace the used cells, and put the battery back together. I thought I had it all figured out, but boy was I wrong.
Nice. Just for your reference, this battery is Samsung. Okay, I've checked the voltages of each cell and it's like this. The worst ones from 3.7, 3.8, those are probably weak. 4.1 seem to be A-okay, but still weak. 4.2, that's perfect, but in comparison to 4.3, it's probably overcharging them because they are undercharged. So those are like the best ones. Now, let's charge them up with this device. Those were 4.3, and that's why my charger doesn't really recognize them because they're overcharged. So I'm trying to discharge them, and I'm doing it in this way. I connected it over to just amp meter right now, and it goes through here to there. And those are like 4 resistors of 10 ohms in parallel, so that they will give me around 1 amp. Should be more, but losses and stuff. So you got 0.9 amps, and I leave it for like 3 minutes, and it drops down to below 4.2 volts, and it's a perfect solution. Also, this is in water so that it's being cooled, because those resistors are not handling 1 amps really well. And I'm getting this cool electrolysis effects in the water. So the idea for the test was to charge up every single battery with the charger and then discharge it to get to like understand what's the full capacity of it. And I thought some of them is gonna be like around 4,000 milliamp hours because that's the full capacity, and some of them will be around 3,000 or 3,500. But in the end, all of them were pretty much spot on 4,000. Sometimes 3,950, sometimes 4,100. So I was like, okay, all of them are supposedly fine. What's wrong? I know that there's not only capacitance that matters in the battery, but also internal resistance, impedance, like voltage drop when connected to a load, which is connected to the internal resistance. I don't have any way to check impedance because I don't have a wave generator, so I only check the internal resistance. I feel like it was really bad. Let me check. I had the battery charged at 3.7 volts. It was connected to some resistance so that the current was 0.68 amps. So the voltage dropped to 3.2 volts. So 3.7 minus 3.2, and this divided by 0.68 amp, which gave me like 0.74 ohms. That's 740 milliohms. This is tragical because supposedly the new battery should have like 13 milliohms instead of 740 milliohms. That's bad. Well, all in all, it turns out that the batteries are not in the worst condition ever. They're just like the capacities are alright. They're just a bit used, and I didn't feel like spending like another 200 euro just for the replacement batteries. I decided to just clean them up, put them back together, and see how the board handles. Maybe it's gonna be the same, maybe it's gonna be a bit better. We'll see. So that's what I did. I charged them all to the same level. They are all right now at 3.7 volts, which is like a 50% of capacity, right? My idea is when I have them all in the same level, and then after having built it, I will charge the battery, they're gonna discharge equally to the same level, and it's gonna increase the battery performance a little bit. Obviously the voltage drop isn't great, it's still gonna die at like 50-40%, but it's still also a test for me, so we'll see. So I bought this spot welder on AliExpress. It's really awesome, battery powered, designed perfectly for welding batteries, welder, and everything else necessary, like this shrink tube, some paper wrap, also this metal to connect it together. So I'm gonna weld it together, keeping the same configuration as the original one. Put it back together and see how it holds up. This is the setup. So basically this is down and up of the battery, and we got 1, 2, 3, 4, 5 batteries in a row. They are doubled, so it's like 1, 2, 3, 4, 5 doubled, and then a second row, 1, 2, 3, 4, 5. So they are connected in series, and this is in parallel, so that it's like the series just adds voltages, 4 volts, 8, 12, 16, 20 volts, and this is still 4 volts but double the capacity. So here we got 20 volts, and this is 20 volts, adding the second row on top, 24, up till 40, actually 42 volts, because there is 4.2 volts in one of them. So we're gonna connect it like it was done previously with those square brackets. I got something like this though, should work. Okay, one side is done. Alrighty, 2 of them done, so I can assemble them this way. Hops. Hops. I just don't wanna touch them so they don't get shorted. Now I want to put a bend in it. And it's bent. Nice. Alright. I did it. I got the whole battery soldered. Basically, I obviously using this machine, I spot welded all the places. Everything is spot welded together. I added, obviously added a new plate over here and spot welded it in place, and also the plus as well. It's done. This is what it looks like. So now it is time to test it. I checked all the connections are correct. I need to test the voltage. Yeah, let's check it. We've got 30.2 volts. Let me collect those leads here. That's what I was expecting. Oh, actually, I didn't. No, I was expecting 37 because it's times 10 and all of them were 3.7 volts. Why? Let's see. This plus and this minus, if I touch it, it does give me 36 volts. But here, from here to there, I'm getting 4 volts drop, voltage drop. Let's connect it to the skateboard. This machine has not been used in over a month now. Alright. Okay, alright, okay. Oh, it's the sound of police. What does it tell me? Battery percentage? Looks like it doesn't tell me. The board doesn't work. Alright, if it doesn't work, let's charge it. Whoosh. got the charger. Let's plug it in. Oh, this guy's talking 52%. The board is on. And we're running. You see? Done. But okay, did I really achieve anything with it besides just disassembling it and reassembling? But I kind of don't want them to charge without my supervision, because I don't trust it. I don't trust myself that much. Let's send off and see when they are fully charged up. Okay, I have tested the battery and I can say it's pretty much safe to use. Some of the batteries are like 4.35 volts, which is definitely overcharged, and some are 4.1. So in total, like supposedly 100% was at 41 volts. Now I just need to make it safe to use by some heat shielding tape and other types of tape, and we'll be good to mount it. Alright, had a small issue. At some point the battery almost blew up in my face just because I shorted the plus and minus from the top and bottom sections. Well, it's fine. I put the sticky paper over here as an isolation. In the middle there is like a plastic isolation piece of plastic with this paper as well, so that it holds it in place. I'm most worried about this place, so I made sure it's never gonna touch, and it shouldn't. And at the top there's also like a rubber seal which seals the electronics from the batteries, because at the bottom of the electronics is also metal, so it cannot short the batteries. Looks pretty damn solid right now. I don't have the correct size of this heat shrink tube which goes over it. It won't fit. I need to buy a better one. Alright, I'm outside. Best thing is running. I hope it's done well. I mean, I've done my best. Testing phase. Everything seems to be working. Alright, now for the verdict. I've been riding the whole day. I rode like exactly 20 kilometers. I still got, so it's 20 kilometers. Let's see how much battery left I have. That was the juice. 12%. And the last, before I fixed the battery, it would die on 50, 40 or like 39. That was the best. 12, that's a fully functional skateboard. Maybe it's not 32 kilometers as they said the new one would do, but 20 is good enough for a 4-year-old skateboard. So I'm happy, yeah? Let's go home!